Example number 2, under the three-moment equation. So we're going to discuss how to solve a beam with a fixed support and a overhang. So last meeting, you all know the equations we're going to use, or the formula in the three-moment equation. Okay, so today I'm going to solve this example and to discuss to you how to solve a beam with a fixed support and a overhang. And before that, we're going to discuss the rules of the three-moment equation regarding fixed support. Okay, so rule here for fixed support. So originally we have a fixed support. For example, this is the fixed support, and then we have a beam here. So for the three-moment equation, for to be used or to be utilized, we're going to change. Let's say this is point, say point M. Okay, so yung point M po natin, so papalitan ko yan. Say this is where the original fixed support is. Ito po yung point M natin. So it will change into a roller support or a fixed pin support. Then i-extend natin yung beam na yan. Okay, from M, we'll extend it to the side of the support, fixed support. Extend natin siya to a length, and then let's say we can write this as a pin support. Then ang length po na extension natin here is, because this is a imaginary length, so the length of this is equal to 0. Say this is the extended part, let's say point O. Okay, and you all know that in this point, okay, at point O, 0 yun. Okay, so this is the transformation that we're going to do whenever we have a fixed support. Right? So before we start solving, we need to check first if it is really a indeterminate beam. Okay, kasi hindi natin magagamit ang geometry equation if this is not a indeterminate beam. So to do that, we have the formula R must be greater to 3n para maging indeterminate. So R natin, how many reactions we have? So fixed support is 3. Roller support is 1, so we have 4. Okay? Just how many members do we have? So we only have 1 member. So that is greater than the 3n. So 4 is greater than 3n. So how many degrees of indeterminacy? It's equal to 4 minus 3. That's equal to 1 degree. So like I discussed on the previous example, the number of degree will be equal to the number of redundant, which is equal also to the number of equation that we're going to be needing to solve the reaction. Okay, so one redundant, one equation kailangan natin. So that equation will be the three-moment equation. Okay, so for this type of structure, yung merong overhang, so tapos natin yung fix, no? Rule for fix, meron tayong rule for a overhang. Okay, so for the rule for a overhang member. So ang overhang member is the BC. Okay, segment BC. So ang ginagawa po natin, going to do is simply consider the segment, the overhang segment, that is like this, no? So BC 6 meters, and then we have 100 kilometers, and then we're going to solve the MB here. Assume positive, so this is the MB. So kinat natin just after point P, after the roller support, and then we consider the right section. So ito na yun, no? Yung segment BC. And then using equations of equilibrium, summation moment at P is equal to 0. Positive clockwise, we're going to determine the value of MB. Okay, the internal moment at point B. So that is MB plus 100 times 6 is equal to 0. So MB here, from the equation, we have negative 600. So negative meaning we have a negative moment at point B. Okay, so next is we can now use the 3-moment equation here. So the 3-moment equation formula, if there is no settlement and there is no or EI is constant, we have here the formula MA plus MAL1 plus 2MB L1 plus L2 plus MC L2. Then we have plus 6A 1A all over L1 plus 6A2 not enough space, so we're going to transfer the last term. We have plus plus 6A2B over L2, which is equal to, well, no settlement, 0. Okay, so MA again is the moment at the left point, and then MB is the moment at the center point, MC is the moment at the left point. L1 is the length of the first span, and L2 is the length of the second span, and A1 will be the moment diagram area of the load at the first span, okay, times A, which A is the distance of the centroid of A1 to the first point, okay, the point A, and then A2 will be also the area of the moment diagram of the second of the load at the second span, times B is times B, where B is the distance of the centroid of the area of A2 to the point C, o yung right point, all over L. Okay? So to this for this example, so yung fix po natin matatransform na yan. Will be like this. Magiging beam natin. This will be the position of the fix, the original position of the fix Then we're going to convert that as a roller, and then we extend. Okay, at the fixed support. This is the point A here, point O ito. Okay, then we have point B dito. Okay, dito yung ating point. So, as you can see here, I remove the overhang. Okay, because we are, ang kailangan lang natin dito is the moment at B, which we already solved, okay, here, negative 600. Okay, so negative moment. So what will be the rotation of MB when we consider the left? Okay, so kapag ka negative yun, negative moment is, yes, clockwise. Okay, so this is your MB, negative moment. And then, we draw the loads. So ito yung loads na consider natin. So this is the 10 kilonewton per meter at segment AB. And of course, yung extended part, wala pong load dyan. Wala din load length yan. And wala din moment sa point O. Okay? So for the 3-moment equation, so we are gonna be needing 3 points. Okay, so point O, A, and B. Okay, so yan po yung tatlong points natin. So from the equation, we have MO, the left end moments, okay, times L1, take LO, okay, plus 2, ano yung center point? Yes, yung point A, so MA ang lalagay natin dito, times L1, that is LO, plus L2, that's L2. L2 here is this part, which is 12 meters. So you can directly substitute the value 12 here. And plus MB, the right point, ito, MB po, times L2, which is 12. Okay, and then we're going to be needing A2B and A1A. Okay, so for A1A here, you can solve that here dito sa baba. So A1 is the area of the moment diagram of the uniformly distributed load. So if we're going to draw the moment diagram of a uniformly distributed load, so we'll have be needing, or we're going to draw it like a parabolic curve, no? Parabola magiging figure natin. Then meron siyang distance na 12 meters, ang span na 12 meters, and we have a maximum moment, which is equal to W L square all over 8. Yan po yung maximum height or the maximum value of the parabola. Okay, so we're going to solve what is the maximum height using this formula. Okay, so we have here is equal to 180. So paano nakuha yung 180? W is 10. Uniform distributed load, 10 yan. And then L square. L is 12 square over 8, so 180. Okay, so this is the area of the uniformly distributed load. Okay, moment diagram of a uniformly distributed load. And this is, so ang A1 natin, class, A1 natin is the factor on the first span. So as you can see, ito yung first span natin. This is the first span, OA. A point O to point A, this is the first span. As you can see, walang load dyan. So first term here is 0. So plus 0 tayo. Then plus for the second term, which is this one, there second factor. Okay, yung 6A2. Ito po yun, yung second span. Yung right span natin. So, this is A2. Diba? A2 natin, we have a formula of 2/3. Yung pang dun sa parabola, no? Area of a parabola, 2/3. Base, it's 12 times height, 180. So, we have A2 is equal to 2/3 times 12 times 180. So we have 1440. And our B here is from the centroid of the parabola to the right point. Okay, yung point B natin, we have kalahati ng 12, 6. Okay, so we have here 6A2, which is 1440. B, ang B natin is 6 over L2. L2 natin is, which is this one is equal to 0. Okay, equal to 0. So, we can now simplify the equation. So, MO and LO, ito yung extended part. So, 0 to. 0 or cancel. Then, LO is also 0 here. So, we have 2 MA times 12. So, pwede natin i-shortcut dito na 24. Yan, 24 MA. Okay, plus yung MB dito, class. Yan na po yung value niyan is ito yung kinuha natin dito sa overhand. So, negative yung nakalagay dyan. So, lagay lang po natin negative 600. Okay? Times, of course, 12. Then, we have plus, ilan to? 6. Okay, we can calculate that. 6 times 1, 440 times 6 over 12. So, we have plus 4, 320 is equal to 0. So, MA here is equal to, let's calculate this one, negative 600 times 12 plus 420. Okay, so divided by 24. Nasagot dito is 2880 over 24. So, ang ating MA is 120. Okay, so 1 positive yung ang ating MA, 120. And then, we're going to determine or to draw the shear diagram. Okay, of course, we can do that if we're going to determine first the reaction. So, take note lang, we have a 120 MA. Okay? So, let's bring back the original figure natin. Fix support sa point A. We have here. So, ito yung nakuha natin MA. So, ang value niya is 120. So, positive 120. So, what will be the rotation? So, as you can see, kino-consider natin yung right portion. Okay, so, right portion yan. So, we have A clockwise para sa positive. So, we have here 120 kilonewton meter. And then, of course, we have the uniform distributed load, which is 10 kilonewton. And of course, we have here di 100 kilonewton. 10 kilonewton per meter. Okay? Then ito is, ang length nito is 12. And ang length nito is 6. So we need to solve here ang ating AY, ang ating BY. Okay, so to solve AY, mag-moment tayo. BY muna. At point A, which is equal to 0, positive clockwise. So, BY ang isosolve muna natin. So, we have 120 in yung moment sa A, plus 10 times 12 times 6. And we have minus BY times 12 and plus 18 times 100. At 18, 12 plus 6 times 100, which is equal to 0. So what is for BY now? Using that, we have 120 plus 10 times 12 times 16 times 6, I should say, minus BY times 12 plus 18 times 1. We have BY is equal to 220 kilonewton. After solving BY, we can solve AY. If we're going to, the advice is to solve using equations of moment, the moment equation. But for me, okay, for this example, sure na tayo sa 220, we can now use summation forces along y is equal to 0, positive upward. So we have AY, we have BY plus 220. Okay, then we have the uniform distributed load minus, because that's downward, 10 times 120. Then we have minus 100 is equal to 0. So what is AY here? Ten times 12, ito. It's 10 times 12. Sure. We have 220 minus 10 times 12 minus 100. So 0. So AY here, we have a 0 reaction force. Okay, and then after determining the reactions, we can now solve for the shear diagram. So for the shear diagram, so 0 yung ating point A. This is point A, point B, C. So 0 yung reaction natin sa AY, so walang paggalaw. Then we're going to have a decrease in shear or move sa negative shear, okay, due to 10 kilonewton. So that is equal to negative 120. Then tataas due to BY at point B ng 100. This is 100. Then constant, diretso ito. Then at point C, mababa ulit ng 100. Okay, so meron tayong change in shear here. So from 0 degree, magiging first degree siya. Okay? And then next is, we're going to draw the moment diagram. So from 0, We have 120, positive yan. So, meron tayong positive 120 dito. And then, magbabago ito at point B, change in moment due to this area. So, what's this area? Plus 1/2 base. So, 12 times height is negative 120. This is negative 720. Yung area nito. From 0, from 120, okay, plus 720. So, we have a so we have a negative 600. Okay, so from negative 600, ito ay magkakaroon ng change in moment at point C due to this positive area of the shear. So that is how much is this area? So 100 times force times the length, which is 6. So we have here 600. So from negative 600 plus 600, we have A. So, of course, hindi ito parabola kasi nga 0 degree. So, magiging first degree lang. Straight po. Okay, so this is the moment diagram of the example. So, this is the shear diagram. This is the moment diagram. Okay, so our takeaway or our learning or the key points, let's say the key points here for today's example is okay, the rule in the fixed support. Okay, so we're going to extend from original fixed support. Okay, mag-extend tayo ng length. Okay, which is 0 rin naman. Okay, and then next is we have the overhang. For the overhang, we can directly solve the value of the moment. Say here MB. Okay, this is for the overhang. Okay, that's it. Thank you.